Hi folks, Mr. Long here. We're going to do a quick logs review just to review what you did in advanced functions more conceptually than anything, just to make sure that you understand all the terminology, etc. So first of all, what are exponents? We have to go back over that, right? So what are exponents? So what I would like you to do is just look at this. 2 cubed equals 8. Okay, it's a really simple thing. 2 times 2 times 2 is 8. But what do all of these numbers mean? So most specifically, we know that 3 is an exponent, the 2 is the base. Altogether, the 2 with the 3 on it like that is called a power. Something that's a common mistake that people make is they say 2 to the power of 3. That is totally wrong. In fact, it's 2 to an exponent of 3, which makes a power. You could say here, for example, that the third power of 2 is 8. You could do that because you're saying a power is 8. But that is not, that 3 by itself is not a power. It's not a power at all. It's an exponent, okay? 2 with a 3 up here, so a base of 2 with an exponent of 3 on it is a power. The answer over here is the evaluated power. So that's after you put it in a calculator or use that calculator in your brain. Okay, so again, 2 with an exponent of 3 on it is a power. That forms a base. And 2 is the base, 3 is the exponent, and 8 is the answer, the evaluated power. So on your y-axis, for an exponential relationship, you always have the evaluated power up here. You always have the exponent here. So, for example, you would have, if this was, if the exponent was 3, well, it wouldn't be 3 there, more like 3 there, you'd go up and hit the curve, and you'd go over, and the answer would be 8. Okay, so with an exponent of 3 and a base of 2, you would end up with an evaluated power of 8. So that's the way an exponential relationship works. So now that we know that, we've reviewed that, let's go back over what logs are. Okay, so what are logarithms? Well, they are the inverse of exponential. So if I do y equals 2 to the x and the inverse of that, I interchange x and y and I get this thing here. And that's an equivalent, that's an inverse relationship. It doesn't look very friendly though, because I usually don't write equations as x equals, I write them as y equals. So what they did, or John Napier, the originator of logarithms, rewrote that in this form. So he would rewrite it, John Napier rewrote it as log of x to the base 2. And so what you're going to notice here, again, x, what is x? X is, in this case over here, x is the evaluated power. Okay, that's what the answer of the exponential relationship is. Your base is right there, 2, and y is just the exponent in this case. Okay, so we can see x is the evaluated power. And so as an example, we would have that 3 equals the log of 8 to the base 2. So what it means is 2 cubed equals 8. So that's your evaluated power right there. And your base is 2 and your exponent is 3. Now, taken all together, that thing forms an exponent, right? Log of x to the base b is an exponent. If we get the answer over here, that is the exponent. So, again, back to our terminology, vocabulary. So for a logarithm, the y value is the exponent, the x is the evaluated power, and with a base there of b. Okay, so, and it does make sense based on what you see here. 2 cubed is 8. So 8 is the evaluated power. So what does it mean if they're inverses, right? So here on the y-axis, we have the evaluated power. This is for exponential. And you have exponent on the x-axis. So that means you inverse. So your x-axis becomes your y-axis becomes your x-axis. And so you have an exponent on the y-axis and an evaluated power on the x-axis. And that's why one of the really efficient ways, say, for example, that you wanted to do a graph of log base 5. Well, we start with a 1 because log of 1 to the base 5 is 0. And your next number would be 5. Your next number out here would be 25. And then if you went way, way, way out here, it would be 125, right? That's one of the quick ways to draw a log graph. And then, of course, here are your exponents. So 1, 2, 3, and so on. Okay, so it would look like this. And then you get all your negative exponents down here. Okay, so that just gives you a bit of thought there of what a log graph looks like. And then now let's look at our rules, because the rules are equivalent, okay, for logs and exponents. So let's quickly go over the rules. So what happens when we multiply powers? Well, in this case, b to the m and b to the n are powers. If I multiply powers, we've known since grade 9 that we add the exponents. Well, that's no different than here, because in this case, a and b represent the evaluated powers. So when you have log of a times b, you're multiplying powers. Well, when you multiply powers, you add the exponents. And remember, up above, we just showed you that log of a and log of b are just exponents. That's all they are. Okay, so you're multiplying powers, you add the exponents. Okay, same thing. The relationships between exponential and logarithm are the exact same. Here, you've known since grade 9 that when you divide powers of the same base, you subtract the exponents. Okay, let's go over to here. A and b represent powers, evaluated powers. If you divide powers, you subtract the exponents. Well, log of a represents the exponent. Log of b represents the exponent, so you subtract exponents. And this is the rule that drives me nuts, really, because they call it power on a power, which isn't correct. Okay, it's not correct. It's actually an exponent on a power. Okay, the power is b to the m, and it has the exponent n on it. So we've known, again, since grade 9, that that's b to the m times n. Well, what's the equivalent way of looking at that with logarithms? Well, that a right there represents a power, the evaluated power. We put the exponent of n on it. So we have an exponent on a power. So why is it that we multiply? Well, we have to remember that when I have just log of a, that's an exponent. So over here, what did you do? You multiplied the exponents together. So when you had an exponent on a power, you multiplied the exponents. It's no different over here. A is the power, n is the exponent that's on that power. So what do? You multiply the two exponents together. N is an exponent, and so is log of a. All right, so again, you might want to copy some of that down, think through it, pause, rewind. But those are some really important ideas with logarithms that you need to be aware of and understand them. Logs are tough to understand, but they are really important. There's really basic fundamental ideas that are critically important. Okay, and so again, I invite you to pause as you went through that, rewind, take down some notes, but make sure you understand those key relationships as it relates to powers, evaluated powers, exponents.